Good morning, students. This is Sheba. Now we are going to discuss about EC8352 signals and systems. Since it is a new subject, first let us get a brief intro of what is meant by these signals and systems. We all know that a signal is a function that conveys information about a phenomenon. In our electronics and communication, it refers to any time varying voltage, current, or electromagnetic wave that carries information. Also, it is stated that a signal may or may not contain any information, and it is a description of how one parameter varies with another. Whereas system is nothing but it is a device that processes the information and produces an output signal in response to the given input signal. So with these few details, now we are moving to the syllabus which we are going to see. So in this subject we are going to cover totally 5 units, where Unit 1 deals with the classification of the signals and systems, and Unit 2 deals with analysis of continuous time signals. In Unit 3 you will be learning about linear time invariant continuous time systems, and in Unit 4 analysis of discrete time signals will be discussed. Finally, in Unit 5 you will be learning about the linear time invariant discrete time systems. Hope at the end of this subject, definitely you will learn a lot about the role of the signals and systems in our technological world. Talking about the textbook, Allen is the referred textbook, and also along with that reference books are also given here for your referring purpose. Here I have also given the NPTEL lecture material references like videos as well as the PDF materials. So moving to Unit 1, classification of signals and systems. First, as I have said, introduction to signals. We know that there are many types of signals like visual, electrical, audio signals, video signals, digital signals, analog signals, power signal, many type of signals, and also many parameters we will be finding from these signals. Signals are mathematical function, that is the dependent variable which are equal to voltage, temperature or flow rate or pressure, etc., and independent variable like time. You can see from this XY graph that a signal is a parameter that varies with time. So here we have marked the independent variable and dependent variable clearly. A signal is a function of one or more independent variable that carries some information to represent a physical phenomenon, which is represented when we are talking in a mobile phone. You can take a real-time implementation of a mobile phone. When we are talking in the mobile phone, the signal will be taken as the input and it is processed in the phone, and output signal is also produced, which is received at the receiver end. So this is the process flow of how the speech signal is taken along the open space. It is taken in the form of electronic signal, EM waves, and it is received at the receiver end. Through antenna and satellite, these signals are communicated. Moving to the application of these signals and systems, they are applied in many areas like communication, aeronautics, circuit designing, acoustics, seismology, biomedical engineering, energy generation, chemical process, speech processing, image processing, and many other real-time applications. As we have said earlier, it is nothing but signal is a pattern of variation that carry information, and the signals are represented mathematically as a function of one or more independent variable. So, Signal involves an independent variable, generally refers to as time, considered, although it may not represent time in specific application. It is a real valued or scalar valued function of independent variable t. Moving to the examples of signal like electrical signals, acoustic signal, video signals, biological signals, and noise is also a signal which is an unwanted, which can be filtered by using the filters. So here you can see the measuring diagram of how a signal is measured in the form of amplitude along with the time period. Moving to some of the definitions, basically we need to know in the signals and systems, voltage, the force which moves an electric current against resistance. Waveform, what does this mean? This waveform, it is the shape of the signal derived from its amplitude and frequency over a fixed time. Amplitude, what is this? It is nothing but the maximum value of signal measured from its average state. Frequency, the number of cycles produced in second. It is usually measured in hertz. Moving to this basic classification of signals. Signals are of two types like continuous time and discrete time namely. So the CT signals, in short, continuous time is said to be CT signals, or take on real or complex values as a function of an independent variable that ranges over the real numbers, and here you can see it is denoted as x of t, which is a continuous sine waveform you can see clearly from the graph. And DT signals, that is discrete time signals, take on real or complex value as a function of an independent variable that ranges over the integers and are denoted as x of n. That is, sample points are chosen over the continuous time signal, which is also depicted in the graph. As this analog continuous time signals plays a major role in the real-time applications, like even the human voice which I am talking now is also an analog signal. We are recognize the sound of limit from 20 kilohertz or less. And you can also see the ranges of AM radio and FM radio mentioned here. All this comes under the continuous time CT signals. Whereas in digital signals, you can see it is represented by square wave. All data here are represented as binary values, that is single binary digit, like that bit, either 0 or 1. Transmission of this continuous group of bits is a bit stream, and here all are represented as a binary values. Talking about this analog versus digital, analog has advantages like it is best suited for audio and video communication, and it's consume less bandwidth available worldwide and also less susceptible to noise. Whereas in digital, it is best suited for computer data processing and can be easily compressed and encrypted. The equipment usage is very less and less expensive and can provide better clarity compared to analog. So analog message, as I have said, it is a continuous form like AM, FM, voice message, whereas digital is in the form of 0 and 1 like VCD, DVD, cell phone, like our mobile phone messaging, etc. Moving to another major criteria, A to D and D to A converters. What is this? This is nothing but analog to digital and digital to analog communication. For example, if I am talking through a mic, through some software to some other foreign people, I will be communicating from my end, whereas they will be in some other remote places. So you need to convert the analog data, your voice, into a digital form which your computer or the device can understand and it can process. And again at the receiving side, it is again converted into analog. So you need an A to D or D to A converter, and this is the major purpose of implementing these converters in real time. So this is nothing but the process of converting the analog into digital is said to be sampling, and it must satisfy the criteria, that is Nyquist sampling theorem, which indicates that our sampling frequency must be greater than or equal to maximum, twice the maximum frequency. Fs is greater than or equal to 2Fm. And another parameter, quantization, that is rounding off the value of the sampled signal to a nearby value, which makes it very comfortable for the process of compressing as well as the transmission of data. So moving to real versus complex signal. Why we are moving to this complex signal? Because they are often analytically simpler to deal with than real signals, especially when we are choosing the digital communication. So these are all about the brief intro about the signals. Now moving to the system, it is nothing but it processes the input signal to produce the output. A system is a combination of elements that manipulates one or more signals to accomplish a function and produces the output, which you can clearly see in the diagram. For example, a communication system is nothing but it is used to transmit and receive the information from source to destination. So here in system, the signal may be analog or digital. When we are dealing with the discrete time signals, it is denoted in terms of discrete times. That is, the sample points are chosen for a specific duration of time. So moving to the important questions regarding this topic which we have discussed. So you need to know what is meant by the signal and system very clearly. This may be asked in 2 mark as well as the 13 marks and 15 marks also in detail. And you also need to know the real-time applications of these signals and systems. So here I have also given the important links for reference along for this particular topic, and also book reference. Dr. J.S. Chittoor, Signals and Systems, page number 1, chapter 1, page number 1 to page number 3 corresponds to the topic which we have discussed. So moving to the elementary signals which we need to know for the implementation of signal. Elementary signals. This is nothing but there are many types of elementary signals like sinusoidal and exponential signals, which is denoted as A sin 2 pi f naught t, and here exponential is nothing but a into e power at. So here theta is nothing but phase of the sinusoidal wave, and a is the amplitude, f naught is the fundamental frequency, and omega naught is the radiant frequency. So moving to the basic signal unit step function. So it is represented as u of t. So this unit step signal is 1 when the time period is greater than 0, and for all the other places it is equal to 0, which you can clearly see from the graph. U of t is equal to 1 for t greater than or equal to 0. Moving to the next one, signum function. So here the value of output is equal to 1 when t is greater than or equal to 0. For other places it is minus 1. So that is also depicted in the graph. For t greater than or equal to 0, this is equal to 1, and for negative areas it is equal to minus 1. Another next one, unit ramp function. So it is a ramp. It increases aggressively along with the time period. For example, for t is equal to 0, it is 0, and for t is equal to 1, it is equal to 1. So for t is equal to 2, it is equal to 2 based on the function we are choosing. For example, ramp of t is equal to t I am choosing. So whatever the t value, it will be taken as the output. For example, if I am choosing t square, means if t is equal to 1, output will be 1. If t is equal to 2, the output will be 4. So based on the function I am choosing, it varies. Next, rectangular pulse or gate function. So that value is equal to 1 by a for the modulus of t is less than a by 2. A is the value which we are choosing. So according to the value of the function which we choose, the output will also vary. Next, unit impulse function. So this impulse is very simple. It is like a switch process. When t is equal to 0, it is equal to 1. For all the other places, it is equal to 0. So this is the representation of impulse function. The area under an impulse is said to be strength or weight. It is represented by a vertical arrow which you can clearly see. An impulse with strength 1, that is value 1, is said to be unit impulse. There are also some major properties of impulse function like sampling property, scaling property, replication property. And also train of impulse function can be generated when we are implementing this impulse in the real-time communication systems and all. Moving to the unit rectangle function, this is represented as a combination of two shifted unit step signals, that is rectangle of t is equal to u of t plus a minus u of t minus a. Unit triangle function, this is nothing but the area which we choose, whose height and area both 1 but its base is not, and it is said to be the triangle function, which you can clearly see from the diagram. The unit triangle through the unit rectangle is said to be the convolution function. Next, sin c function, it is nothing but sin c of t is equal to sin pi t by pi t. It is a continuous function. Next, discrete time signals, it is nothing but sampling is the acquisition of value. As I have said, from continuous signals, discrete signals are extracted by using the sample points, by choosing specific sample points at specific time instance. So discrete time exponential and sinusoidal signals, these dt signals, x of n is equal to a sine of 2 pi f naught n plus theta, where n is the discrete time, which discrete sample points which we are choosing. A is the amplitude, theta is the phase shifting radiance, and a0 is the discrete period of the wave, and f0 is the discrete frequency. Here you can see clearly discrete time sinusoidal signals, how sine wave is represented in this as discrete sample points. Next, discrete time unit step function or unit sequence function, u of n is equal to 1 for n greater than or equal to 0. It is similar to the unit step function which we have seen for continuous time signal. The only difference is instead of u of t, you will be representing as n. There continuous is represented as t. Here n is the discrete sample points. And also again unit ramp function for discrete time signals, r of n is equal to n for n greater than or equal to 0 and 0 for all the other areas. Discrete time impulse, del of n is equal to 1 for n is equal to 0 and 0 for n is not equal to 0. Unit pulse sequence continued. So here del of n has some properties like scaling property, but sampling property, but it has no scaling property, that is del of n is equal to del of an, which the a integer decides the value of the impulse function. So regarding this topic, you need to clearly know about the questions like impulse function, step ramp function. So these are all the important questions, how you can apply this in real time. Here I have also given the important links for reference, and book reference corresponds to Dr. J.S. Chitod, Signals and Systems, page number 3 to 14 corresponds to the topic which we have discussed now. This is about the topic content of presentation for a few topics which we have discussed now. So regarding the real-time application, as I have said, mobile phone, satellite communication, everything comes under the signals and systems. So everything operates based on these signals only. So if you have any doubts in this, you can ask me and get the details. Thank you.